Hi everyone, welcome back. So GFG problem of the day today is wildcard pattern matching. This is a hard question, but we will make it simple and we will see what are the different things in this and edge cases and how we can optimize it using DP. So what is the question? We are given two strings, pattern and str, which may be of different size. We have to return 1 if the wildcard pattern, that is pattern, matches with the string, else we have to return 0. All the characters of the string and pattern always belong to the alphanumeric characters. Now the wildcard pattern may include characters that is question mark and star asterisk. So the question mark matches any single character, means question mark can match to any other single character. Only one character it will match with. And star can match any sequence of characters including the empty sequence, means empty 1, 2, 3, any length of characters it can match. Now the matching should cover the entire string, not partial string. We have to match for the entire string. So this is the question which we have to do. So how shall we do this? So first thing that comes to our mind is these two we can consider like two operations for which we can have two different calls. So we can think of recursion like we do LCS using longest common subsequence using recursion. That is, we take two strings, keep two indexes, and if the character matches we keep move ahead, or any other conditions we can change the calls. So that is the basic thing that comes to our mind, and we will solve using the same approach. So moving to the solution part, we want a recursive function. We have to pass our pattern and string and two indexes for first pattern and second for string. So we have passed 0 0. Now if our recursive function returns true, we have to return 1, otherwise we have to return 0. So this is the basic thing. Now moving to the recursive function, we have taken all the inputs. Now what shall be the base cases? First base case that comes to our mind is the positive that both strings are completely matched. So I also reaches its length and the j reaches str.length. If both strings are complete, means we have matched the complete string, so we have to return true. This is the first test case, base case. What can be the second base case that comes to our mind? The second base case is we do not have to match partial strings, so what we can think is if I reaches pattern.length and j reaches its str.length, means both have not met. If both had reached their length, it would have returned from the first base case itself. If it has not returned for first base case and it moves to the second, means only one of the two have been fulfilled. So that means it is a partial, means either j is remaining or I is remaining. So we can think that in that case we had to return false. So we return false. These shall be our base cases. Now we have to write our logic. So we take characters first from pattern, second ch2 from str. Now we have kept a flag, that is a result of all our calls. So we have made it initially assumed it false. Now we will put our condition. So the first is if both the characters are matching, then we just have to move ahead. That these characters have been matched, we have to move, check others. So we have written flag or. This or will do if any call returns true. So it will make our flag true. So that's why we have used or, flag or equal to, and a recursive result. So we have just increased I and increased j if the characters are equal. Second is if our ch1, if this is not true, but if our ch from pattern is question mark, it can match to any other single character. So in that case also we can just move ahead. So these two conditions we have handled using this call. Now the other case shall be for the star. If these two have not fulfilled, now we have to check for star. If our ch character from pattern is star. For star, what can be the case? For star, the case shall be that the str string moves 0 characters, 1 character, 2 characters, or any length. So what we have to do, we have to put a for loop from j to str.length for all the lengths. That means basically we have matched our asterisk, so I plus 1 and k for str any length k, and we will keep doing all the calls, means we are matching our asterisk with any length of characters in str string. So we have made all the calls. At last our result will be in the flag. If any call returns true, our flag will be true. So we have to return that. So this is the basic solution that we think of when seeing this question. Now let us see what are the edge cases and where our logic fails. So we are running this solution. So see, our logic fails in this case. Now let us try to think why our logic is failing. So first comes star for that any can match, but I is not completed and j might be completed. So here there is a problem, but it will match for all the lengths. So first it takes nothing, so it moves, then C, D, D, D all would have been matched, and at last I would have been on a star, but our J would have been completed after the first call. After the first call, I increases means asterisk covers with nothing, so and remaining all the patterns are matching, so it moves ahead. At last I would be at the star, but J would have reached its length. For this case, when we see, we have put a base case that if a partial string is complete, means one is partially completed, other is fully completed, so we have returned false. So this is why our case code fails here. Now why is it so? We know that partial matching we do not have to do, but this is a star character at the end. Star character means it can match to any, but we are not putting any logic for that. So this is a edge case, so we have to handle it separately in our base case checking. How will we do this? I hope you guys would have understood why it was causing a problem. Because it is a star, it can match to empty, but we have not put any logic for that. We are just, if the j reaches its length, we are returning false. So we have to handle it in our base case matching. So we will handle it now. Now if the I reaches its length but j has not reached, that means it is false. This is completely sure. Means pattern is completed but the string is left, so this is not complete matching, so it is false. But if our j means a string is completed, now we have to check if all the characters from I to the length are star, then that means it is fine. They will match to null characters, empty characters. But if anything else is remaining after the star, any other character, that we have to match. So we will just check, we will put a loop from I to pattern.length. If all the characters are star, then we will return true. But if there is any other character from I to length except star, that means we have completed the J string but pattern is not completely matched, so that is false case. If all are star from I to length and J is completed, then it is true. So this is the other condition we are handling, the error we were getting. Because if our J is completed and remaining I to pattern characters are all star, then it is fine. Then it is truly matched. Now let us see what is the final error that we get. We get means our solution is correct, but we get time limit exceeded. This is a common problem in recursive solutions. Now how shall we do this? I just made a video on the 01 knapsack where I demonstrated how we convert recursive solution to dynamic programming, that is top-down approach recursion plus memoization. So the same we can do here, because we have I and j, two varying indexes, that we can create a DP table, store the results and optimize our solution. We will do the same here. Now we just have to introduce our DP, that is we have to add memoization to recursion. So we have created a boolean DP because result is always in boolean. We have two varying variables, that is I and j, so both will be used in our DP. First I is for pattern.length, second is for str.length. We have created our 2D DP. We have passed our DP, we have taken input in DP. Apart from all these base cases, now what we will do, if we have a stored result, that is dpij is not equal to null, we will return the result from dp. We will return the result dpij, and what else we have to do, we have to add dp to the calls, and at last we just have to store the calculated result in our dp. Means we are memorizing it, and if we have a already computed answer, we are returning it. So simply we have converted our recursive solution to the DP top-down approach, recursion plus memoization. So this is how we converted a hard problem to a simple recursive solution using our basic recursive logic. Once we can write a recursion, we can convert and optimize it using TP. So this is how we use TP to optimize our recursive solutions. I hope you guys would have increased your understanding of recursion and TP using this problem. Thanks for watching the video. Have fun. Bye.